Alrighty, welcome back to Elementary Algebra. I'm your instructor, Amy Fuchsteiner. This is going to be section 3.1 today. We are going to look at how you do some graphing on a rectangular coordinate plane. All right, so some of the things we need to talk about to begin with. We want to make sure that you understand that a coordinate plane, don't want to give anybody vertigo. A coordinate plane is also known as a Cartesian system that is based on an x and y axis. The x-axis is the horizontal axis that crosses the plane straight across. The y-axis is the vertical axis. So somewhere around here, I'm going to make a vertical line as best I can. This is known as your y-axis. Again, the horizontal is known as your x-axis. These two axes could be placed anywhere on the coordinate plane to make the Cartesian system. Their intersection is located at a point we call 0, 0, and the origin. So the origin is the point 0, 0. This coordinate plane is based on 4 quadrants. The vertical and horizontal line split it into 4 quadrants. The quadrants may seem a bit odd because the top quadrant here is known as quadrant 1. This is actually the top right quadrant, and it is quadrant 1 because in this place, both the x coordinate and the y coordinate are positive numbers. Working counterclockwise, the quadrant 2 is above and this time to the left. In this case, the first coordinate would be negative and the second coordinate would be positive. Quadrant 3 is below. This would be a negative quadrant. And quadrant 4 is the remaining. This would be a positive value and then a negative value. All right, these are your 4 quadrants. Again, quadrant 1 is positive. I'm going to write this as positive, positive. There we go. That makes a little bit more sense. So each one of these quadrants are characterized by their movements on the Cartesian system or on the coordinate plane using the Cartesian system. We mark those movements using an ordered pair that is blank, comma, blank, right? And those ordered pairs are made up of 2 coordinates. The x coordinate covers your horizontal movement, left and right. In this case, if you are moving to the right, that x coordinate will be positive, and if you are moving to the left, that x coordinate will be negative. All of this in relationship to that origin or intersection point of 0, 0. The y coordinate covers your vertical movement. Again, this one is up and down. And in this case, up is indicated by a positive movement and down is indicated by a negative movement. So the first thing we want to do today is we want to practice a little bit of graphing. So we're going to look at some points here. And we need you to be able to do 2 things with these points. We want you, when we give you the coordinates in the Cartesian system, to be able to graph the points. And if given an actual point on a graph, we want you to be able to give us the coordinates based on the Cartesian system. All right? So here we have a graph with 4 points on it and another section where I've asked you to plot. So we're going to start with the plotting of the points and then see if we can work things backwards a little bit so that you can get the coordinates out. So the first point we've asked you to plot is 3, negative 3. Where do you start? Find your x-axis and your y-axis. Their intersection, the point 0, 0, or the origin is your starting point. So from this point, this 3, -3 tells us we're going to move 3 places positive. So we're going to move 3 places to the right and then 3 places down. The second one is negative. So this is where the point goes, and we're going to label it with the letter it's given. This is point E at 3, -3. Point F also begins at that origin 0, 0. Notice my first coordinate, the vertical back and forth, left and right, is 0, meaning I'm going to not move off of that origin point. And then I need to go up 6. So 1, 2, 3, 4, 5, 6. That is point F. Notice again that I am putting a capital letter to indicate the name or label on the point. Third point is -6, -1. The negative tells me I'm moving left 6. 1, 2, 3, 4, 5, 6. Down 1. We're going to put the label of a G there. And then the last point of H is a -4/5 and a +4. -4/5 is not all the way to a -1. So when you're given this type of point on this type of system, what you want to do is go almost all the way to a 1 and then up 4. 1, 2, 3, 4. This is point H. In many cases, you will be asked to approximate. It's okay if it's not right on every corner. I call the corner ones pretty points sometimes, but it's all right if it's not exactly on that corner. You should still be okay to be able to approximate where it is. All right. So what do we do in determining the coordinates of the points A, B, C, and D? Well, for point A, we see that it's over here, all the way in quadrant 3. So quadrant 3, right, because this would be quadrant 1, quadrant 2, quadrant 3, quadrant 4. So all the way over here in quadrant 3, I just need to count. I need to figure out how many over it is because that's my first number, and then how many down. So 1, 2, 3, 4, 5, 6, 7, 8. So it is 8 units to the left. 1, 2, 3, 4, 5, 6. And then 6 units down. So the coordinates of point A are -8, -6. The coordinates of point B, notice again, we don't go off of the x-axis, so I'm not moving left or right at all. And then I'm going down 1, 2, 3, 4, 5.5. So a negative for down, 5.5. Or 5.5, either would be fine. Point C is 1, 2, 3, 4, 5, or 5 over. And then it's not moving up or down, so that's a 0. Point D is in quadrant 2, and I'm going to go back 3. And then up 1, 2, 3, 4, 5, 6, 7. Right? Each one of those have now been given coordinates. I usually double check them because sometimes my counts are off. I'm a math teacher. I can count sometimes. Okay. Now, our next goal in this is to be able to graph or plot things into a plot points from a table into a graph in order to demonstrate the relationship between those two pieces of information. So we're going to look at some data that's been organized into a table, and then we're going to visualize it in a graph. So the table here shows the property tax rate on the north side of La Crosse for the first 5 years of home ownership. So in the first year that the home was owned, the property tax was at 3.6%. The second year property tax was at 4%, the third year at 4.4%, the fourth year at 4.8%, the fifth year at 5.2%. Now, if you own property in La Crosse, you probably recognize that our property taxes are considered to be high and that they keep rising. But property taxes are what pay for education and several other things. Whether or not you Believe they're high or not, I think they're probably high. They do serve a purpose. So, okay, we're going to plot this information and see what we can figure out. Sorry, I had to turn this a little bit more. It's annoying me. Okay, so our years owned is our first, that's our first part of the relationship. We are going to put the years here on the horizontal axis. So these are the years owned. I'm going to make sure to label it. 0 years owned, 1, 2, 3, 4, 5, 6, 7, 8. Notice I'm putting them on the line here and not in between. The property tax percent goes all the way up to 5.2. So I want to make sure 1, 2, 3, 4, 5, 6. Yep, I've got enough. So my first, so if I do 1%, 2%, 3, 4, 5, 6. So I'm just going to do like 2%, 4%, 6%. You don't necessarily have to label every step of that graph. Okay. Now I am going to graph this table by doing 1 and 3.6. I'm approximating, but that's okay. There's my first point. My second point is at 2, 4. My third point is at 3, 4.4, 4 and 4.8, 5 and 5.2. All right. This is what the graph would look like. And then I want to plot or draw the line that would connect them. So this is about, right? And you see I'm letting the line go off the graph a little bit. That's fine. What does the point 3, 4.4 mean? That means that after 3 years of them owning the home, the property tax is at 4.4%. Okay. What would the property tax be after 6-ish years? So we're just estimating, because I don't know that exact point, and I can't necessarily predict for certain what the property tax will be in 6 years. But if we look at the previous years, we'll see that in year 6, it's above 5.5. So I'm going to say about 5.6%, because it looks like it's just above 5.5%, but not quite all the way to 6%. So I'm going to say 5.6. 5.7 would be okay. All of those would kind of work. In what year do they expect the tax rate to be 6%? So I'm going to find 6% and come over, and I see that's right there. That's going to be right about year 7. So even though I don't have data on years 6 and 7, I can use the previous years to approximate what that data will be, particularly if I've put it into an organized graph. Right? We have a graph here where we're going to ask you some questions. So in this particular case, it appears that we're looking at time in minutes as compared to the heart rate. So here the heart rate is 60, 80, 100, 120 beats per minute, 140, and 160. What we're looking at is maybe somebody exercising. So here we have a warm-up period, and then while they're training, and then a cooling down. So describing the graph in words basically means that we're asking you to describe what this graph is giving us, what data it's recording. This graph, because I've got time in minutes and heartbeats, appears to be tracking somebody's heartbeat as they're exercising. It appears that as they're warming up in the first few minutes of exercise, their heartbeat is rising. And then at some point it levels off and they're able to maintain a steady heartbeat as they exercise. Then somewhere around the 40-minute mark, they begin cooling down. They've stopped exercising. So their Heartbeat is increasing, then it levels off over time, and then cools down again, slows down again. All right. That's my description of this graph in words. I got really dark again, didn't I? Hello. Okay. Sorry. Sunshine, middle of the morning. What can I do? All right. Problem number 2. What information does the point -1060 give us? So over here, we've got this point -10, and then we're at 60. I believe that what this tells us, since they started exercising here, right? That's where they started and going up. I believe that the point -1060 is telling us what their heartbeat was prior to starting exercise. So 10 minutes before they started exercising, because it's a -10, it's before they started exercising. So 10 minutes before they started exercising, their heartbeat was at 60. So their resting heartbeat was at 60 beats per minute. 3, after beginning their workout, how long does it take to reach the training heartbeat? So if they start here at 0 and the training heartbeat starts right there, we're looking at 10 minutes. Okay. At what time was the heart rate 100 beats per minute? So if we look at 100 beats per minute and follow it across, we can see that we reached 100 beats per minute on the way up and on the way down. So there's 2 of those. So I would say at about 5 minutes and at, where are we here? About 50 minutes. So these are approximations, but that's okay. Get as close as you can based on the diagram in front of you. What was the heart rate 8 minutes into the workout? So 8 minutes into the workout, if this is 10, 8 minutes is going to be right here. Oh, I don't know, about 140 beats per minute, BPM. Okay. So what we're asking you to do is to look at these graphs and make sort of educated type, not guesses, but approximations. All right. Given the graph below, answering the following questions, describe the graph in words. This is a graph of a map. Along the bottom of the map, we have numbers to record a section, and along the vertical axis, we have letters to record a section. This appears to be a map of Rockford, Illinois. I know it's really hard for you guys to see. And I'm afraid I'm going to try and focus. There we go. Did that get better? Yeah. Okay, it appears to be Rockford, Illinois. It's just a little small, so I can get stuff in here. So it appears to be a map of Rockford, Illinois, with numbers for reference along the horizontal axis and letters for reference along the vertical. What would the coordinates be of Rockford? Okay, so if I'm looking at Rockford, it's right here. Along the vertical, that is 5, and along, along the horizontal, that is 5, along the vertical, that is B. So I would say that Rockford is in the region 5B. What cities lie in D3? Oh, looks like I should have said B5. Okay. I don't like when it says D3. I like 3D. I'm going to do that, 3D, because this should be, to keep it consistent, this should be 5B. Although, I'll be honest, if somebody said B5, I would know exactly what they were talking about, right? Like, B5, I could still do. All right, so what city or cities lie in 3D? So 3D, it's kind of hard to see what that is. Oh, man, I should have thought about this. I can't read it. It's too small for me. That's what I get for my eyes going. All right. It's Mount something. Mount Morash. Mount Morash? Okay, great. Where is the intersection of Highway 251 and Interstate 88? Now, Interstate 88, I know, is this one going down the bottom. 251 is, where's 251? This one? So I think that's Devon. So I'm going to say 2E. And then I've got, what are the coordinates of Woodstock? Woodstock I know is up here. That's Woodstock. I can just see that. So I'm going to say 8B. Okay. All right. In the actual computer program, that picture is much bigger. So it will be easier to read, I believe. I don't know what, it still bothers me. I can't know what that word is. Oh, well. It's only so much a girl can do. All right. Given the graph below, describe the following, or answer the following questions. Describe this graph in words. The nozzle held at a 60-degree angle, nozzle held at a 30-degree angle. Oh, I know what this is. Okay. So this one's a little bit tough and it's a little bit hard to see, but that's a sprinkler. So what are we showing here? We are showing the spray from a sprinkler if that sprinkler head is held at 60 degrees and if that sprinkler head is held at 30 degrees. So the blue line represents the water spray. If the sprinkler head is at 60 degrees, points 60 degrees up, and then the red line is if the sprinkler head is 30 degrees up. So what angle does the water shoot up higher? Well, 60 degrees. The 60-degree angle gets the water to shoot up higher. How much higher does the water shoot up? Ooh, okay. So in the red one, it levels off here, and in the blue one, it levels off there. So that's a difference of 3 to 7, so 4 feet. Okay. At which angle does the water shoot out further? Well, further would be the red or pink one. So that's going to be at the 30-degree angle. How much further does it go? Well, the red one goes all the way out to 7, the blue one to 3. So again, it's 4 feet. Okay. So it's whether or not you need the water to be high or far. Who knows? As a kid, I would have wanted it high. Would have wanted it high to run underneath the sprinklers. That's the truth. All right. So our last type of graph here is a specific one. This is known as a step graph. The step graphs are graphs where the increments occur in steps. The increments are jumps that actually create steps in the graph itself. Step graphs are used in higher mathematics, but step graphs on a day-to-day basis, you use step graphs a lot. It's how we used to pay for, well, maybe not anymore. It's how we used to pay for like data usage. You would reach a certain level and it would be the same price all across that level. And then it would jump up $5-10 when you got to the next level. You see step graphs when we look at parking. If you've ever had to park in a parking ramp, that's a step graph, right? Because every hour is a jump. They don't count it by minutes usually. Usually every hour or half hour is a jump. If you pay for a taxi or an Uber, you're probably using some sort of step graph payment. You pay by the mile or the half mile, or in some cases, the fifth of a mile in New York. So if you go just a little bit further, you pay the whole next one, is the point, right? Okay. So what is this graph? This graph in words tracks the pricing of the rental of skis. It compares the rental period in days to the total amount charged. Okay. Find the charge for a 1-day rental. For a 1-day rental, that charge is $20. Now, the straight line here, the step, means that anything less than a day still gets charged $20. So even if you were only going to rent the skis for 45 minutes, you would still pay $20 for the rental. They don't prorate it based on the number of hours. It's solely the number of days. If you've had them for any time in a single day, you're paying $20. So any days over 1, right? So at one day you're paying $20 and the next jump is $40. Oh, this goes here. Okay. So at 2 days you start paying $40, 3 days is $50, 60, 70, 80, 90. Why the open circle? Right? Why are we starting with an open circle? Because at the end of day 1 you owe $20, but if you still have the skis when you wake up in the morning on day 2, you now owe 40. Because it jumps in that instant, we have a closed circle at the bottom one and an open circle at the top one to show that even 1 day and 1 second gets you an additional charge, theoretically. Okay, so skis are rented from 8 a.m. on a Monday to 11 a.m. on a Wednesday. How much are they charged? They have the skis for all of Monday. They have the skis for all of Tuesday. And then they have the skis for part of Wednesday. So they have them for 2 full days plus some. That means they're going to get charged for 3 days. The first day is 20, second day is 40, but then on the third day, they are getting charged the extra amount. So they're getting charged $50. Okay. Can you estimate the charge for a 10-day rental? We know that a 7-day rental would be $90 and that we're getting charged $10 more for every additional day. So I'm going to estimate, because I don't have that exact data, I'm going to estimate that a 10-day rental, if possible, would be that $90 plus another $10 each of the 3 days for $120. It's a guess. I could call the place and they could say, oh no, we charge $150 because after a week there's extras, but who knows? If the skis were rented for $90, so that's $90, how long were they rented for? $90 tells me they had to have been rented for 7 days. Okay. All right, that's it for 3.1. I was going to say 7.1, but that's it for the first section of chapter 3. Hopefully you have an idea of a coordinate system and plotting points, and you're able to take some paired data from a graph and put it on a graph, and that you're able to read some graphs of varying types, line graphs mostly, but some step graphs and some other types of graphs in there as well. Okay. Thank you.